Hi, Miss Sahar, it's me, Adham. I hope you enjoy my project, um, and I hope you like it. And I will see you in the quadratic function. In algebra, what is a quadratic function? You may ask me. In algebra, a quadratic function uh, or a quadratic polynomial is a polynomial of the second degree. It means it is x to the power of 2. It also has one or more variables in which the highest degree term is of the second, which means, for example, I have x to the 2x to the power of 2 plus x plus 4. Characteristics of a quadratic function. Of course, any type of function has its unique characteristic, and in today's case, we're going to learn about the characteristics of a quadratic function. It has many characteristics, such as it has a y-intercept and an x-intercept, a vertex, an axis of symmetry, a domain, range, a minimum or maximum value, and opening of the graph. If you ask me what is the opening of the graph, then I can answer you that it takes like a U-shaped graph. It opens upwards or downwards. There are two forms in which quadratic functions are written. Each form has its kind of advantage, so it is helpful that you write both forms. First, standard form. A standard form is when the equation is written by this form: y equals ax to the power of 2 plus bx plus c. This is this is a quadratic function in the standard form. We also have another type, which is vertex form. Vertex form is when the equation is written in the form y equals ax a multiplied by x minus h to the power of 2 plus k. For example, a standard form equation is like 2x to the power of 2 plus 4x plus 9, while a vertex form equation is like 3 bracket 4x minus h to the power of 2 plus 5. Our first drill or example. Write this function, which is negative 2 bracket x minus a to the power of 2 plus 12 in standard form. The solution for this question is by converting it to the standard form into the standard form formula, which is ax squared plus bx plus c. And for me to convert this function into standard form, I have to expand it by using FOIL methods, which is multiplying the first two digits and the last two digits, and in the middle I will multiply the outers and the inners, which we will see in the following steps. At first we have the equation, then x minus 8 to the power of 2 will be divided into x minus 8 multiplied by x minus 8. Then I will multiply the first two digits, which are x and x, and the last two digits, which are negative 8 and negative 8. Then we will multiply the inners and the outers, which will be done by multiplying x and negative 8 and x and negative 8, giving us giving us the equivalent of negative 2 bracket x to the power of 2 negative 16x plus 64 plus 12. Then we continue by adding and subtracting to get the final standard form equation, which is negative 2x squared plus 32x minus 116. The what is a vertex in a quadratic formula? A vertex in a quadratic formula or a quadratic function is the highest or lowest point of the graph of the function, and it's found in the point where the axis of symmetry intersects the graph. The vertex is also known as the maximum or minimum value according to your graph, which we will discuss later in our presentation. In the standard form equation, which is ax to the power 2 plus bx plus c, some people may ask me, how do I find the vertex? The vertex, we will find the vertex by using the following rule. Neg- Negative b over 2a. For example, I have an equation, 2x power 2 plus 4x plus 9. Then how will I find the vertex? At first, negative b, what is the b? The 4. Negative 4 over 2a, which is 2 times 2, it will be 4. 4 over 4 equals to 1. Then the x point of the vertex will be 1. Then function of negative b over 2a, it means I will substitute x in both equations by 1. In the equation by 1. So it will be 2 multiplied by 1 to the power of 2 plus 4 multiplied by 1 plus 9. Which will be 2 plus 4 plus 9. Which will be 8 plus 9, which is 17. So our vertex will be 1 and 17. And now also the vertex has its own form, which is the vertex form of the quadratic function that we discussed earlier in this representation, which is a bracket x minus h to the power of 2 plus k. The vertex of the function is located at this point, which is h and k. Which means if I have the equation in vertex form and I want to know what is its vertex, then I will take the h, which is the second digit in the bracket, and the k, the last digit in the equation. Moving on, we have an example or a drill, which is find the vertex of the parabola given by this function. The parabola, if you may ask me, is the U-shaped graph drawn by the equation. For example, I want to find the vertex of this equation, which is 2x minus 4 to the power of 2 minus 5. What will I do? It's simple. Earlier, here we return to the previous slide. We said that the vertex in the vertex form equation is the h, which is the second digit in the bracket, and k, the last digit in the equator. In our case, we have 2 bracket x minus 4 to the power of 2 minus 5, which means our vertex ordered pair will be negative 4, will be 4 and negative 5. Then, moving on, we have the domain and the range of a function. What is the domain and what is the range? A domain of a function is the real input which is possible of all x values. Which I mean, by saying this, any x values that are possible in the input of this parabola or equation. The range of a function is represents all the mean possible outcomes for the output or the y values of the parabola or equation. Moving on, we have the x-intercepts. What are x-intercepts? X-intercepts is where the graph of the function touches or crosses the x-axis. Keep in mind, when we used to find the y-intercept, we had to have the value of x equals 0. For example, a y-intercept is like 0 and 4. Here in the x-intercept, we must have the value of the y equal to 0. For example, 4 and 0. This is an x-intercept, but a y-intercept is 0 and 4. Also, a quadratic function can have one x-intercept, two x-intercepts, and sometimes zero x-intercepts, which means that it doesn't touch the x-axis at all, and it is floating only without touching the x-axis. Here we have a drill. What are the x-intercepts of this function? The function at first is x to the power of 2 minus 6x plus 9. First, to find the x-intercepts, as we said earlier, we need to make the value of y equal to 0. Then we will substitute y with 0, so our equation will be 0 equals x bar 2 minus 6x plus 9. Then we need to simplify or factor the equation, which will make it 0 equals to x negative 3 multiplied by x negative 3. Then we will make all the values equal to 0. So it will be x minus 3 equals 0 in both sides. Then x will be equal to 3. So we have the same value of x-intercepts, which means that this equation has only one x-intercept, or 1 0, which is 3 and 0. Moving on, the y-intercept, as we said earlier in this video, or in explaining this PowerPoint, that the y-intercept is when you have the value of x equal to 0, like our example earlier 0 and 4, 0 and 5. But don't be mistaken, the x-intercept is the value of y equal to 0, but the y-intercept is the value of x equal to 0. For example, what is the y-intercept for the following equation of the parabola or graph? The equation is x to the power of 2 minus 4x minus 12. How can we find the the y-intercept? We said that we must make the value of x equal to 0, which means I will substitute x with 0, so it will be 0 to the power of 2 minus 0 x minus 4 multiplied by 0 minus 12. 0 to the power of 2 equals 0, and any number multiplied by 0 equals 0. Then the value that will remain for me is negative 12. Then the y-intercept is 0 and negative 12. Moving on to the next characteristic of a quadratic formula equation or parabola is the minimum or maximum value. A minimum or the maximum value is the highest value or highest y or highest range in the parabola, while the minimum value is the smallest or lowest range or point in the parabola. To determine whether a quadratic function has a maximum or a minimum value, we need to observe the graph. If it opens upwards, then it has a minimum value, but if it opens downwards, then it will have a maximum value. The shape of a graph of a quadratic function is a parabola, which is a U-shaped graph. And since it's a parabola, it has an interval of an increase and interval of decrease. These intervals are also based on the direction that the graph opens up. For example, if it opens up, has a different interval than when it opens downwards. If the leading coefficient is a positive number, then the graph will open upward. And if the graph open upward, it will decreases to an interval of negative infinity and h, and it increases on the interval h and infinity. If the leading coefficient is negative, then the graph will open downward, which means it will decrease on the interval h and infinity, and it will increase on the interval of negative infinity and h. Here we have another drill, which on which interval is the following function decreasing. Solution. In this problem, a, which is the integer beside x to the power of 2, equals to negative 3. Therefore, the function decreases on the interval h and positive infinity. How to calculate the value of h? First, we will make our rule of vertex, which is negative b over 2a. Where is the b in this equation? It is 6. And it will be negative 6 over 2a. A equals negative 3. 2 multiplied by negative 3 equals negative 6. Then negative 6 over negative 6 equals 1. Then if h equals 1, then the function decreases on the interval 1 and infinity. Next, we have the axis of symmetry. What is the axis of symmetry? An axis of symmetry is the vertical line that passes through a parabola's vertex. Remember when we said the vertex is where the axis of symmetry divides the parabola? Yes, this is the axis of symmetry. And it has and we have many ways to find the axis of symmetry. In the standard form equation, which is ax to the power of 2 plus bx plus c, the axis of symmetry is given by this formula, negative b over 2a, which we use to find the x value of our vertex. But in vertex form, we use another formula. We use the formula of x equals h. Here we have another drill or question to help us understand this explanation. What is the equation for the axis of symmetry for this quadratic function, which is negative 3x to the power of 2 minus 12x plus 3? Our solution is in this function, the a, which is negative 3, and b, which is negative 12. How to find the axis of symmetry? We will use our formula, which is negative b over 2a. But here we have negative 12, and as we learned before, negative equals positive. Then it will be positive 12 over 2 multiplied by negative 3, which means 12 over negative 6, which is equal to negative 2. Therefore, our axis of symmetry is x equal negative 2. Now, we move towards the transformation rules for our function. If x plus b shifts the function b units upward, which means the value of b, the function of x plus b, the value of b shifts the function for b units upward. But if x negative b, it will shift it b units downwards. B units upward or downward, it means the value of b. For example, if it is f of 3 plus 4, then it will shift it 4 units upward. But if it is fx if function of 3 minus 4, the equation will shift 4 units downwards. If the equation if function of x plus b, it will shift, the function will shift b units to the right. And if it is function of x minus b, it will shift b units to the right. For example, if it is function of 3 plus 5, then it will shift 5 units to the left. But if it is function of 3 minus 5, it will shift 5 units to the right. And if it is negative function of 3 of x, it will reflect the function in the x-axis, which is upside down. For example, if it is negative function of 3, then the graph will be reflected upside down. Here we have another drill, which is graphing the function of y equals 2x to the power of 2 minus 5. If we start with y equals x to the power of 2 and multiply the right side by 2, it will stretch the graph vertically with a scale factor of 2. Then if we subtract 5 from the right side of the equation, it will shift the graph 5 units downwards, as we can see in the following figure. Here we have another drill, graphing this function, which is negative half multiplied by x minus 3 to the power of 2 plus 2. If we start with y equals x to the power of 2 and replace x with x minus 3, then it will have the effect of shifting the graph 3 units to the right. How to solve a quadratic equation using factoring? To solve a quadratic equation using factoring, we have 4 steps. The first step is transforming the equation to the standard form, in which one side is 0. The second step is factoring the non-zero side. The third step is setting each factor to 0. Note, you need to remember that a product of factors is 0 if and only if one or more of the factors is 0. Therefore, we will solve each resulting equation. Here we have some examples so I can clarify what I just said. Here in this equation we have x to the power of 2 minus 3x minus 10 equals 0. The left side, which is x to the power of 2 minus 3x minus 10, I will factor it, which giving me x minus 5 and the x plus 2. Then I will set each factor to 0, making each equation equal to 0. So it will be x minus 5 equals 0 and x plus 2 equals 0. Then I will solve each equation by making 5 go to the other side and 2 go to the other side. So it will be x equal 5 or x equals negative 2. Then my solution set is 5 and negative 2. Here another example is 2x to the power of 2 plus 5x equals 12. This is one of our special cases. We will take 12 and transfer it to our left side, making it negative 12 instead of positive 12. Then I will factor the side, giving me 2x minus 3 and x plus 4. I will factor them to 0 and solve the equation, giving me the results of x equal 3 over 2 or x equal negative 4, giving me a solution set of 3 over 2 and negative 4. Here we have another method to solve our quadratic equations, which is completing the square. What is completing the square, you may ask me? Completing the square is one of the methods that we use to solve a quadratic equation by changing the equation's form, so that the left hand side, which I use it to make all the work on the equation, is a perfect square trinomial. Here in this example, 7x to the power of 2 minus 8x plus 3 equals 0. I will take the c, which is 3, and I will transfer it to the other side, giving me 7x to the power of 2 minus 8x minus 3. Then then if I divide it by 7, it will be x to the power of 2 minus 8 over 7x equal to negative 3 over 7. Then x minus then x to the power of 2 minus 8 over 7x plus negative 4 over 7 to the power of 2 will be equal to negative 3 over 7 plus 16 over 49, which gives me x minus 4 over 7 to the power of 2 equal to negative 5 over 49. Here it will give me positive or negative 5 root 5 over 7 and some imaginary numbers. We will factor more. It will give me x minus 3 to the power of 2 equals to 12. Then x minus 3 I will square root will be equal to positive or negative root 12. Then the final result will be 3 positive or negative 2 root 3. Here, our next method is solving quadratic equations by using the quadratic formula. Unlike some of the other techniques that we have discussed earlier, which are solving by factoring, solving by completing the perfect square trinomial, there is a way to solve any quadratic equation, like any quadratic equation that you may think of, in the standard form, which is ax power 2 plus bx plus c, which is substituting the values of a, b, and c into this equation, which is the quadratic formula. X equals negative b positive or negative root b squared minus 4ac over 2a. Here is an example illustrating how we can solve this quadratic equation, which is x to the power of 2 minus x minus 12 equals 0, using the quadratic formula equation. First, we need to find out the values of a, b, and c. What is the value of a? It is x squared, which means it has a value of 1. What is the value of b? It is negative x, which means it has a value of negative 1. And c is negative 12. Then second, we will substitute these values into the formula, which was negative b positive negative root b squared minus 4ac over 2a. Then after we substitute, it will be negative 1 positive negative root negative 1 to the power of 2 minus 4 multiplied by 1 multiplied by negative 12 over 2 multiplied by 1. Then, which will give us the result of 1 positive negative root 1 negative 48 over 2. Then we need to simplify our result, which will be 1 positive negative root 49 over 2, which will give us 1 plus 7 over 2 and 1 minus 7 over 2. When we solve the equation, it will give us the values of x equal 4 or x equal negative 3. And here we have finished our PowerPoint project. I hope I hope you enjoy the project and that you have learned something new today. Thank you, and we will see you next